speciation, and we're just going to talk about what a species is and how we get new species. So this picture shows us two different species of spotted owl. So they have a common ancestor. However, these are two different species at this point. And so we have the northern spotted owl, and we find that in the northwestern part of the United States, and the Mexican spotted owl, which we find in the southwestern and into Mexico. These are different species, and so we're going to look at how we know they're different species and how they ended up being two different species. So first, there's lots of different definitions for a species. We're going to use the biological species concept. And the biological species concept tells us that a group of organisms that can interbreed, so a population that's interbreeding naturally, not through like a liger where we take a lion and a tiger that would never mate in a natural environment. So we're not including those. So in natural conditions, and their members produce fertile offspring. So here we have two different larks, and these larks look very similar to each other, but they are in fact two different species. They have different songs, and they would not interbreed with each other. This is an example of the same species that look very different. So here we have two different, we have the same species of ant, but they look very different. But this is an interbreeding population, and they produce fertile offspring, so therefore they are of the same species. Here's an example where we're going to see species that can interbreed, but not produce fertile offspring. So here's a horse, and a horse is a species. We can put horses together, and they'll interbreed and produce fertile offspring. These are donkeys. Donkeys are species. They interbreed, produce fertile offspring, and we can interbreed these. We can cross a donkey and a horse. However, a donkey and a horse is not considered the same species because their offspring, which is a mule, is sterile, cannot produce offspring. So the mule, if you want a mule, you have to go back to a horse and a donkey to get your mule. So they can interbreed, but they can't produce fertile offspring, so therefore a horse and a donkey are not the same species, and a mule is not a species because it can't even breed. So how do we get these different species? And this process is called speciation. So here's a little cartoon, and we have these fruit flies, and these fruit flies have developed a different preference for food source. So these guys are preferring papayas, and these guys are preferring bananas. And so now they're adapting to different environments, and over time, if they change enough genetically, adapting to these different environments, different selective pressures, that when they bring them back together, they can no longer mate and produce fertile offspring. You now have a speciation event. So this is an example with just little blobs. So here we have two populations, and these are interbreeding. We have gene flow between them. But if something happens to create a barrier, and so that these guys can't exchange genes, over time these guys are adapting to their environment and the differences in that environment. These guys are adapting to their particular environment and differences in that environment. And over time these differences accumulate to the point where they are genetically dissimilar. And now if we bring them together, they are no longer able to mate and produce fertile offspring. That is a speciation event. And the last thing I want to leave you with is just the difference between gradualism and punctuated equilibrium. So Darwin kind of explained evolution as a process of gradualism. So organisms gradually changing over time, descent with modification. Here we have a speciation event, and so these guys are descending with modification on a separate branch. But again, it's this gradual process over time. The fossil record does not always support that. The fossil record shows us many periods of time where there's no changes occurring. We're showing this as a straight line going up. So this would be equilibrium. There's no change. It's equal. Things are the same. And then that's followed by a period of rapid change in the fossil record. We may have another period of equilibrium followed by rapid change. And when we look at these periods of rapid change and we compare them to what was going on Earth at the time, we find that there was rapid change going on Earth at the same time we see these rapid changes in organisms. So that kind of makes sense. If the environment is not changing, there's nothing to really adapt to, so we will see less changes going on with species. And then periods of rapid change on Earth, we're going to see lots of different adaptations and variants that are going to be selected for in that rapidly changing environment, and then we'll see this punctuation and equilibrium over this period of rapid change. So this is the last slide. I hope this helped.